On the back of your proportional analysis, you need to choose the first.
We had this idea that we were going to create a mission to Mars so that they could learn about some geometry concepts within a sort of STEM environment while also learning about space.
Okay, so 120 and negative 30.
They started out by exploring Mars both on a NASA tool where they could zoom in, investigate craters, look at the different altitudes, and then they also could take a walk on Mars by putting on the VR headset and being immersed in actual footage from one of the Mars rovers. Then they have to collect samples on the Mars map. Now the Mars map is on the floor and their rover right now is a Sphero, but in order to recreate the idea of working in mission control on Earth, they have to sit in front of the panel and adjust to not being directly in front of the Sphero. They can't grab it and move it. It's 100% just where it is and trying to make their adjustment.
A little nudge.
Just so you can see how it travels.
Good job!
They are having to do some proportional analysis to figure out, well, it's this much on my map. How many kilometers is this actually on Mars? So they have to look at what they're driving in the classroom, but what is that if you were actually on Mars in space?
So 1, 2, 3, 4, 5, 6, 7.
Okay, so how are we like, don't go to the edge. That's not where the...
The last thing that they will do is code a spike robot. They'll get to see some rounding errors because we're talking about 1 centimeter is 800 kilometers. So they're going to make some decisions on rounding, and then they're going to code their robot to go this many centimeters on the floor for our big Mars map. And they're going to have to see, oh, well, my coding actually took it into this crater, and that's a problem, so I'm going to have to go back and revisit. So they're using their own math and then their own coding skills to iterate on actually making the rover go where they want.
We're doing the same worksheet, but we're independently working.
And so then they're going to have to take the shapes that they collect and analyze those for volume and surface area. So we're basically doing all of our geometry on area and circumference of circles, volume and surface area of different shapes, proportions. So we're revisiting a variety of our math SOLs in the context of real life, where they're doing all of the math and then doing something with it.
Why did you put 1.5?
Add like 1 more centimeter to this one.